What up YouTube, this is Benjix Fan 3 here. I'm talking quietly because my family is trying to sleep, and although I want to respect them by being as quiet as possible, I also have to be able to speak through this microphone so y'all can hear me. Anyway, so I kind of rage quit doing question 1 of chapter 4, so I'm going to do question 2. This is going to be completely improv, but I looked at the picture of the question and I actually know how to solve these kinds of questions, or hopefully I do. Anyway, so let's get started. I'm not going to write the question on the board. I'm just going to hope that it's in front of you and you can read it yourself. So what do you know from this question? First off, you know this is your given, and you have a 635 Newton thing right there. And as you can tell in the diagram, it's pointing downward, which probably means that there's a force acting on it. No, it's acting a certain amount of force, because Newton always means force. And so we're going to say that the force of applied by this weight, so I'm going to say force of, I'm going to put it as question mark for now. I will explain why later. Alright, so we know that there's two cables, and cable 1, the angle is at 45 degrees. And we know angle 2 is 43 degrees. And we know that they're both string. Now, what don't we know? They're asking for the tension of the first string. So you have to go unknown of tension in the first string. And they're asking for it in newtons. So you say in newtons. Now you might be asking yourself, what is a newton? But if you remember this equation, F equals ma. This equation will get you far. Please remember it. It's pretty much the basis of all kinematics that I remember. So this is saying Newton is equal to kilogram. Let's make the kilogram a little bigger. Kilogram, and then times acceleration, meters per second squared. That's what a newton is. Newton is your weight times your acceleration. Alright? So, hopefully you have that written down. I'm about to erase this off the board. And if not, always go back to my video and pause it. So in the picture, we have pretty much this. And that's a mass. Alright? So what do we have from here? We have to figure out all the forces. We have to draw a free body diagram. Alright? What forces are acting? Well, what we could do is do the forces acting on this, or we can do all the forces acting where all the forces seem to be acting on that dot right there. So what forces are acting on here? We have a pull down from this guy. We have this being attached to there, so there's a force being attached to this end right here. And we have a force going this way because it's attached to this end right here. So on our FBD, we have a force of gravity. We have force of tension number 1, and we have a force of tension number 2. That is our FB. That's showing us all the forces that are acting right now. And right now we can actually make this into a grid by adding dimensions. So this is going to be the y-axis, and this is going to be the x-axis, where if that's 45 degrees, this is 45 degrees. That's 45, that's 45. And if this is 43 degrees, this is 43 degrees. Alright, so what do we know? If this is the x and this is the y, what do we know? Well, or actually, yeah, I can do this. The forces in the x direction is force of tension 1 and force of tension 2. Force in the x direction is force of tension 1 plus force of tension 2. And we know in the y direction, it's force of gravity plus force of tension 1 plus force of tension 2. Now, the only thing that I did not mention in this is cosine and sine. Now, in all the x's, there is a cosine, and on all the y's, there's a sine. I'll write it right here. Cosine, sine. And the reason I did not include that is because I don't have enough space to write all that. But I have enough space here, so I can show you all the things we did. The only reason I wrote it like this is, one, I don't have enough space, and two, because I just want you to know the forces that are acting. What is in this x direction, y direction? You can see that the force of gravity is right dead center of the axis, so it's not going to affect the x-axis. It's only going to affect the y. So you could say f of an x direction is equal to ft1 cosine of the angle that it's at times or plus force of tension 2 cosine of the angle that's at plus f of g cosine of the angle that's at. But since that's at a 270 degree angle, this just turns out to be 0. Alright, so that's why I didn't write all of that out. Hopefully you understand. Now, what we do, hopefully you've written that down. I'm about to erase this all off the board. Please just take a moment. Alright. Not erase that. Alright, back to the question. So now that we have this labeled in the x and y direction, and we know this force, what else do we know? Well, as you can tell by this picture, the forces are actually stable. They're not really moving, are they? This is stayed in place. That's the tension. The string's not moving. It doesn't say they're moving within this thing. It is in equilibrium. It is balanced, and for our purposes, it means all the forces, which means net force. All the forces acting together on it is equal to 0, because force means that it's moving in a certain direction, or there's a force. Sorry, that's velocity. I'm sorry. Force means that there's an acceleration applied in a certain direction, which means that it is increasing in speed. And since these are all at 0, this goes back to Newton's law, saying anything at rest tends to stay in rest, meaning it's going to stay at rest until acted upon an unequal force. And since all the forces are equal to each other, ta-da, the net force is 0. So all these are going to cancel out at each other. I'm going to rewrite this on the board. F of x, since now that I have more room to write it, I will write the force of tension 1 cosine of the angle it is at. I'm saying this is tension 1, this is tension 2. I'm saying the angle that is at, oh my lord, why did that pop up? Is at 45 degrees plus the other x, this one right here, plus force of tension 2 cosine of 43 degrees. And you can add this one in here if you really want, but it'll turn out to be 0. Force of gravity times cosine 40, oh sorry, it'll be 270 degrees. Actually, yeah, because it's from the center of here, so this angle is just this angle. This angle is this angle, and this angle is on its own. That's going to be 0. Pretty much is just cancel it out. I'm just going to save you some time. You have that, and those two balance each other out. So this all, if I make it bigger for you, is equal to 0. And also, in long-term short, or long story short, f of y is equal to, let me make that bigger for you, and separate from this, f of y is equal to f of t cosine, oh sorry, sine, y is sine. It's like midnight right now. Sine of 45 degrees plus this tension 1, force tension 2, sine 43 degrees plus force of gravity sine 290 degrees. It's going to be equal to the 0, because if that's 0, then that means all forces are equal. That means x and y cancel out, x and x cancel out, y and y cancel out. So all of it is going to equal 0. And with this, you just plug it in to try to figure out what the answer is. First thing you can do is try to solve for that for one of them, then plug it into here to make it simple for you. That's actually what I would do. I'm about to show you how to do that. I might have to erase this picture though. Hopefully you have written it down somewhere. Alright. You better pass this class. I love you too much. Anyway. So, plug it. What we're doing right now is solving for we're solving for tension 1, right? That's the unknown we wrote beforehand. So how do teachers do this? F T1 is equal to, and if you do all the algebra, solve for F of tension 1, and you will end up with negative Ft2 cosine. Actually, is that 45 degrees or is that 45 plus 90? You know, do you know what I'm saying? 43 plus 90. 1 second. No, actually, because I wrote it like that, I think it cancels out in the end. So, cosine of 45 degrees divided by cosine of 40, this is 43 degrees. 45 degrees. And that's how you solve for 1. But if you want to solve it for 2, which actually I think would be the smarter way of doing it, so you can eliminate it later. Force, but either way, it doesn't matter which one you do it, you'll end up with the same answer, but this way we'll just get it to you quicker. Please do it both ways. Please do it, try it at least both ways, so that you can try to check yourself for the answer. I'm not saying it's a smart idea. I'm saying it's for your own practice. I'm just going to do it this way for the sake of time. It's equal to negative Ft1 cosine of 45 degrees over cosine, I'm so tired right now, 43 degrees. Alright, that is F2. Now we can use this equation right here, plug it in, and we will eliminate F of 2. So right now we don't need this anymore. Because since we solved it for 0, we figured out that equation. And now, next equation. So this is still equal to 0, right? This is now F tension 1. It's the force of tension 1. Sine of 45 degrees plus F2 cannot be replaced by negative Ft1 cosine of 45 over cosine 43, still multiplied by sine of 43 plus, and I'm just going to put this over. We already know that this force is going to equal the force it's given because it's all in the y direction. So I'm going to just save you some time. It'll end up being negative 635 newtons. And the reason why is because, back to the chart, here's force of gravity, tension, tension. It's all downward while these are both upward. So this is actually going to be a negative sign because I'm going to say that this side's positive, this side's negative. And you know what the fun thing about physics is? You can make this positive and these negative and it still won't affect your answer. Because it is just that fucking awesome. Anyway, I think I still might have made a mistake with this angle calculation. You might have to add 90 to it. I'll check myself afterward, but for now, that's all I'm saying. So now all we do is solve for force of tension, And that's gonna end up being a whole other side of the board. Sorry, I'm once again improving this question because I am too lazy to go through it once and then show you all my work. Okay. So, force, it's a T. Force of tension 1 is equal to, and you have to do all this work of solving it out. So, FML, I was too lazy to do that. What can we do here? Oh, this is gonna be 685. From there, you do that. Some more algebra, you get the common of these, and it would be divided by sine 45 minus cosine 45 times sine 43 all over cosine of 43. My handwriting is getting sloppy the more tired I'm getting. It'll be that, and to solve for that, you just plug it into a calculator. Technically, this number right, this cosine would go to the top, so you can do that as well to help you solve on my calculator. It doesn't matter how you plug it in. Cosine of 43. As long as you get the right answer. 635 cosine 43 divided by, hopefully I get the right answer. Either that or I'm missing 9 degrees off that. I'm sorry, I'm just so tired I can't think of whether I need those 9 degrees or not. And you get the answer of 2065.317. Now to check your work, plug that into there, solve for f of 2. Which is why I was telling you to solve for that anyway. But either way, again, this is how you check your work. I told you either way could work, which is why I was still correct. So, negative cosine of 45 divided by cosine of 43. In a negative, it's saying negative on my calculator, but that's all because of direction. 1996.845. Now to check if this is right, we need to actually plug it back into the equation. So, long story short, you do the cosine, sine of everything, and see if it makes sense. So back to the FBD. This is and I'm going to erase all the other stuff. Hopefully you wrote that down. So let's go back to the diagram. We have a force of tension, This is gonna be, I'm just gonna say force 1, force 2, then force G. G-force, lol. Sorry, I'm running it sideways. F, B, D. You already drew this picture. Hopefully you didn't just draw it again. If you did, then you are just not paying attention. Alright, so this, the x's have to cancel. So this the cosine of that, f2 cosine of whatever degree it was, so degree is going to be equal to f1 cosine of whatever angle that turns out to be. So let me plug it in just to make sure. This turns out to be 1460.4, or about that. And now that side, oh, look at that, 1460.4. Those two equal out, so it's a check for the x. You have to check both though. Force of x, force of y. Check for that. Now let's do check for y. So what we have to do is 0 is equal to the force of gravity sine of its angle, which is going to be just a negative force of gravity, plus force 1 sine of its angle, plus force 2 sine of its angle. And that all has to equal 0 because they all should equal out. And I'm about to do that math for you because it'll save me some time. So we know that's going to just equal 635. So 635, oh, negative 635, sorry. Plus force 1, which is 2065 point. Oh, actually, I have it stored in my calculator as a number. Sine 45 plus b sine 4/3. And actually on my calculator it says I am off by 536, so I messed up somewhere. What did I mess up on? Yeah, it's in the green mode. I'm so freaking tired. $635. Maybe I'm off by 90. I'm gonna add 90 to this. It shouldn't make a difference though. Yeah, let's just cancel those. What am I messing up? I have to draw a diagram for a second, I'm sorry. I'm messing something up here. This is why you do the checks. This is going to be 43, and that's the x. So if you want that, you have to do opposite over hypotenuse. So that would be that number times the sine of degrees, right? Yeah. For some reason this is canceling out on me, which isn't making much sense. Why is that 98? Oh, I realized what the problem was. Or did I? B is a... Okay. That still isn't making sense. This is already turning out to be a 30-minute long video that isn't making sense. What am I doing wrong? Am I forgetting those 90 degrees? No? What the hell? There's that. This is what I get for improving it. I mean, those two numbers cancel out. Maybe if I changed a little bit. That makes even less sense than before. So what I just did on my calculator is that I barely switched the numbers around. Oh wait, that's 3 or 4. Nope, never mind. It's consistent and it's error. Or am I error? Oh my gosh, this is already turning every more than 30 minutes. What the hell? Long story short, you wanted to know how to get it started, not to figure out the answer. I'm so sorry. It's midnight right now. It's 12:31 to be exact. I got off from work tired. I can always redo this video tomorrow. And I can't think. I'm just overtired. Hopefully my video helped you understand how to start it. Just draw pictures and just say what you know. What do you know? What do you not know? What variables can you deal with? What's another name for that variable? Etc. Anyway, I have to go to sleep because I'm about to die. I'll not die, like crash. So this Banjo-Band 3 here is saying sorry I couldn't finish the problem, find my error in the problem. But I still hope that that helped you out in understanding how to solve the problem. I'm so sorry.